Bigolo, meaning Leonardo the Traveler from Pisa. He was an Italian mathematician. Well, we all know because Pisa's in Italy, and he was considered to be the most talented Western mathematician of the Middle Ages. Aside from the Fibonacci sequence, he's also known for Liber Abaci, this one. Liber Abaci. It is a historic 1202 Latin manuscript. So in this book, it popularized the use of Hindu-Arabic, the current number system we are using right now. That's Hindu-Arabic. Because back then, what people use is the Roman numerals number system, courtesy of the Romans. I'd like to emphasize this. Fibonacci did not invent the Hindu-Arabic numeral system. It was the Arabs who made use of it. Just some recall. I, of course, that's 1. V is 5x10. L 50, C 100, D 500, and M 1000. And if you see a bar on top, for example, V bar, that's 5 times 1000. D bar means you have to multiply it by 1000. D bar, that is 500,000, and so on. Alright, just a short exercise. What number is this? MCM LX IX. What number is this? MCM LX IX. Come on, people. Make it fast.
Pumasok ako sa room. Nababantik siya pag ginagawa. Umiiyak siya doon sa may mirror. Tanga ka, hindi dyan yung daan dito sa may kapila.
Alright, we have there 1969. How about if we write 2024 into Roman numerals? That's MM, and then 24 is XXIV. MM 2000 XX, that's 20. IV, that's 4. That's why, of course, when we were in elementary, isn't it that after our name, we write our grade level. For example, grade 4. Grade 4. We should write it this way, not this way. This is the incorrect way of writing 4. It should only be the I with a bar, with a horizontal and line up above and below the vertical line. Ayun. So imagine if we're using Roman numerals, for example, if we multiply 50 times 50, that is obviously 2,500. So that's Indo-Arabic. But if you make use of Roman numerals, can you do it that way? No, because L times L, 50 times 50, that's 2,500. So we have MM and then D. MMD. LL, you multiply these two numbers, the answer is MMD. Parang out of nowhere yung pinanggalingan. Unlike if we make use of Indo-Arabic, we have this. Now, what are the Fibonacci numbers? The Fibonacci numbers are defined by the following recurrence relation. F sub n equals F sub n minus 1 plus F sub n minus 2, wherein n is greater than or equal to 2 with F sub 0 equals 0 and F sub 1 is equal to 1. For the Fibonacci numbers, F sub 0 is always 0. Why? Because we always start with nothing. And then from nothing comes 1. Comes 1. Now, if we need to compute for F sub 2, note, F sub 2, F sub n. So in here, our n is 2. So if you compute for F sub 2, that is F sub n minus 1, F sub 2 minus 1, which is F sub 1, plus F sub 2 minus 2, which is F sub 0. So F sub 2 now is equal to F sub 1 plus F sub 0. That's why we have here f sub 2 is equal to 1, since 1 plus 0 is 1, or simply 0 plus 1 is 1. Same story applies until the nth f. F sub 10, that is f sub 9 plus f sub 8, 21 plus 34, or 34 plus 21, that's 55. F sub 12, that is f sub 11 plus f sub 10, 89 plus 55, we have 144. And then I asked you actually yesterday to compute the Fibonacci numbers f sub 13 to f sub 21. What is f sub 13? That's 89 plus 144. So we have
233, sir.
233, correct? How about f sub 14?
377, sir.
377. F sub 15?
610, sir.
610. F sub 16?
987, sir.
987. F sub 17 is it 1597?
Yes, sir.
Alright. For F sub 18 to F sub 21, you verify if my answers are correct. 2584, correct?
Yes, sir.
For F sub 19, 4181, is it?
Yes, sir.
And then we also have F sub 20, 6765, correct?
Yes, sir.
And then we also have the last one, 10946.
Yes, sir.
So those are the first 21 Fibonacci numbers. Again, for referencing, we assign f sub 0 as 0 because just like what I said a while back, we always start from nothing. These are all Fibonacci numbers. Here's the concern. What if you are tasked to compute f sub 60? What if you're going to compute f sub 60? Using this relation here, f sub n equals f sub n minus 1 plus f sub n minus 2, that would be f sub 59 plus f sub 58. So again, if you're going to compute for f sub 60, you should add f sub 59 and f sub 58. However, there's another problem here. Before you can solve for f sub 60, you should know the values of f sub 59 and f sub 58. And for you to know those values, halimbawa, f sub 58, you should know first f sub 57 and f sub 56. Same story. For you to know f sub 56, you have to know f sub 55 and f sub 54 until f sub 0 actually. That's the concern. Thus, we have here this third subheading. Can we easily calculate large Fibonacci numbers without first calculating all smaller values using the recursion? The answer is yes. There is a simple and non-obvious formula for the Fibonacci numbers. We call it the Binet's formula. So the Binet's formula is given by f sub n equals 1 over square root of 5, and then open bracket, then open parenthesis, then you have this 1 plus square root of 5, the sum divided by 2 raised to n, and then minus, open parenthesis, 1 minus square root of 5, the difference over 2, and then raised to n, and then you have here the closed square bracket. You have to memorize this one. You have to memorize this one because this will, I mean, in the exam, of course, it's closed notes. It's closed notes. And if I'm going to ask you what is f sub 30, you simply substitute 32. And so you have to memorize this. Don't worry, this is very easy to memorize because 1 plus square root of 5, the sum divided by 2, that is actually the golden ratio. And if you are to check your output in the divine phase activity, in the second box, you'll see there 1.618, which is the approximated value of 1 plus square root of 5, the sum divided by 2. Based on the table above, we found out that f sub 10 is 55. We can verify this value actually by substituting 10 to n. By substituting 10 to n. And so we'll get 55. By the way, next week, yes, you have to bring your scientific calculator for the correlational analysis and regression analysis topics. Try this using the Binet's formula. For f sub 35, what's your answer here? F sub 35? 9.
Ano tuloy ako kung paano siya tawagin. Ano bang ate or
What's your answer in f sub 35? 9227, is it?
7465.
Alright, thank you. How about f sub 40?
102334155,
33415.
55.
Ayan, so with the help of the Binet's formula, it would be easier now for us to compute the Fibonacci numbers. Unlike if we simply make use of the recursion formula as presented above. Again, we read this as Binet's formula, not Binet. It's Binet. Binet's formula. Next, let's have the golden ratio. Consider the table below. What pattern can you observe and what number is being approached? So in the first column, we have here the n values. And then second column, f sub n. Third column, f sub n minus 1. If our n is 0, f sub n is 0. Well, that's already given. And there's no f sub n minus 1. Because there's no f sub negative 1. There's no f sub negative 1. If our n is 1, f sub n is 1. Since f sub 1 is 1. And then f sub n minus 1 is 0. Since this will become 1 minus 1. So that's f sub 0. And the f sub 0 is 0. Well, of course, we can't divide a number by 0. That's why these areas here are in black fill. Now, in the last column, you'll see here f sub n over f sub n minus 1. I'd like you to check the quotients.
Ang pangit, di ako makatap ng screen.
Starting off with 1. The first quotient is 1. The second quotient is 2. What happened? Did the quotient increase or decrease?
Decrease, sir.
Decrease or increase? Increase, right? Yung 1 naging 2, so there's an increase in the quotient. How about the next one? 2 and then 1.5. What happened? Increase or decrease? Obviously, decrease. And then 1.5 to 1.6667. What happened? The quotient increased. And then, same story, decreased, increased, decreased, increased, decreased. So if we are to actually graph this one, it's like this, no? For example, if you are about to meet the Lord, increase, decrease, increase, decrease, increase, decrease, increase, decrease, increase. Ayun. Hanggang sa ayun. Kay San Pedro ka na. Ayan ha. So ganyan yung pattern niya. Ganyan yung pattern niya. Increase, decrease, increase, decrease, increase, decrease. Tapos may ina-approach siyang number. May ina-approach siyang number. So kung mapansin nyo, yung ina-approach niyang number ay approximately 1.618. And that is the golden ratio. That is the golden ratio. The quotients follow an increase-decrease trend whilst approaching a particular number equal to 1.618. That number is actually the golden ratio or the golden mean. Other names include golden section, extreme and mean ratio, medial section, divine proportion, divine section, golden proportion, golden cut, golden number, and so on. And they consider it as the most beautiful number. Most beautiful number. Golden ratio. It is the most beautiful number. So if you have your own most beautiful woman or most beautiful individual,
Mas maganda
we also have this what
ano
we
kung
call most beautiful number. And if
nag-aano,
you remember in the activity,
mag-aral ka.
the last question there, do you have a divine
Dapat
face?
lang,
Most of you
Pero hindi ko pa tas
no, just like mine, may ilan, yes. So yung mga yes, congratulations. Talagang pinagbutihan yung paggawa sa inyo.
Ako yes. Ano
Ayun. Let me just share this one. Most
Alam mo yung ano?
beautiful in the world
Ano daw?
according to the golden
Yung
ratio.
divine face na yun. Ginawa namin.
Let's-
Tas ano?
According to the golden ratio. Most beautiful woman in the world according to the golden
kahit
ratio.
ginamit mo daw, ay kahit
We actually have Bella
84
Hadid.
and below,
So Bella
ano siya,
Hadid is the world's
ginawa ka
most
out of
beautiful
lust.
woman
Pag 85
based
and,
on the
under
golden
100,
ratio.
ginawa ka out of love. Nakuha ko 97.
Pero may
Ayun,
iba
sa
sa inyo
mga
naka 100,
contest na
naka
yan.
100. So ibig sabihin mas maganda ka kay Bella Hadid.
Ayun no, sana all divine face.
Let's first consider the
7.
gentleman as well.
Tapos sabi ni Sir, pumutok, ay, nabutasan ako.
According to sino to? I'm not sure how to pronounce the name correctly since this is French. British naman daw. Page. According to research, in some resources they say that it's Robert Pattinson. Robert Pattinson as the most handsome man in the world. 2020. This is 2023.
Sabi ko na.
So this is the most recent one.
Ilagay ko dito underwear.
Yung nasa Bridgerton. I don't find him attractive. I'm sorry. Bridgerton. Alright, so yan lang. Golden ratio has its own Greek letter. We have P. It's like number 6, pero medyo with a twist. Ayan. Well, phi is irrational. Same true with pi. It's also irrational. What are irrational numbers? These are non-repeating and non-terminating. If you want to know more about irrational numbers, you can make use of the real number system. And then, what is the exact value of the golden ratio? We have this one. 1 plus square root of 5. Network issue sabi. 1 plus square root of 5. The sum divided by 2. Ayun. And of course, we also have the golden rectangle, golden spiral. Wherein if we divide the length by the width, that should be equal to the golden ratio. Okay? So yun lang, mabilis lang tayo. What you need to remember here in relation to your final exam, to your midterm exam, is the Binet's formula, of course. I'm not sure if I'm going to ask some questions about Roman numerals, but we'll see. We'll see it from there. Binet's formula, we have to memorize it. Fibonacci sequence and golden ratio, they're like husband and wife. They always go hand in hand. Ayun. And we can actually observe them in nature, in art, in architecture, and so on. For example, if you are to look at your hand right now, you see 5 fingers, right? And 5 is a Fibonacci number. You have 2 eyes, 2 ears, and 2 is a Fibonacci number. If you are to look at your pointing finger, there are 3 partitions, and 3 is also a Fibonacci number. I ask you to actually read this. Flower petals. If you are to count the number of petals in this picture here, there are 5. If you are to count the number of petals of chicory, it's 21, daisy 34, and so on. We also have seed heads, pine cones, fruits and vegetables, tree branches, especially Janice work, shells, spiral galaxies, for example, the Andromeda spiral galaxy, hurricanes, typhoons, of course, faces. That's why you had your divine face activity. Fingers, animal bodies, reproductive dynamics. For example, in honeybees, there are more females than males, and if you are to divide actually the number of females by the number of males, if you divide those numbers, the answer is approximately 1.6. Note that in honeybees, females always outnumber males. Why? Because the females, the only job of the males is to copulate with the queen. Now, kung wala na siyang silbi, anong ginagawa nila? Pinapatay nila. Luckily, hindi ganyan sa tao, right? Animal fight patterns, DNA molecules. So, from very microscopic to telescopic galaxies, the Fibonacci sequence and golden ratio, can observe them. Well, of course, in terms of art, we have Leonardo da Vinci with his Mona Lisa. We also have the Vitruvian Man. The Vitruvian Man, ito yun. The Vitruvian Man. This one. Okay.
A rule of conduct
The Vitruvian Man.
is an obligatory. A rule of conduct is an obligatory.
Well, that ends my topic. Sabi ko kanina, mabilis lang tayo. Alright? Ito yung share ko sa kanina no, sa LiveGen. Na-download na. Tignan lang natin, baka magamit nyo. Ayun po.
An obligation is
Fundamentals of Cost Accounting o 754 pages pa. Well, syempre sa inyo kasi Filipino authors, right? Tignan lang natin yung table of contents. Ayan. Okay. So yun ha, kung maghahanap kayo ng books online, kasi tinatamad kayong magbuka at maghiram ng book, pwede kayong magtingin dito. Lalo na pag international.